In figure, O is the center of the circle, BD and OD are equal, and we have CD to be perpendicular to AB. So that's already marked. We'll mark this point of intersection as T. So we need to mention that. First thing is we have the diagram. In the diagram, what should we do? I don't know if this is useful. I'm going to join OC. So we did join OC, and we are calling the point of intersection. Let T be the point of intersection of AB and CD. Okay, then anything else? Yeah, I think that's it. Okay, what do we have over here? We need to find one angle to move across. Without any angle, we can't do. So we have CTB to be 90 degree. Okay. But it's neither on the circumference of the circle or on the center. So it's not going to be that useful, at least not directly. But we have one weird information, that is BD and BO are equal. We have to make use of that. So somehow we can make use of that and do things, So for that, I'll consider, since we are trying to figure out an angle, we'll consider a triangle OBD. Okay. So this has a peculiar situation. We have OD is equal to BD, and in sense, it's an equilateral triangle. Why? Because you have OB to also be a radius, is it not? So this is a radius, this is a radius. So we have two sides to be equal, and even the third side is equal, is it not? So we'll just end up writing the following. In triangle, this particular triangle, we have OD is equal to DB, right? Both are equal to radius. So this is given. Right? And also OD is equal to OB because they are radius. Is it not? This implies triangle OBD is an equilateral triangle as all sides are equal. Make sense? And now we got an angle at the center, angle DOB to be equal to 90 degree. Not 90, sorry, 60 degree. Okay, how will we make use of this? So this is 60, that's good, that's good. How will we make use of this? See, if I have to figure out, let me go to the main thing now. If I have to figure out angle ACB, this particular angle, what should I consider? Well, I should consider this, is it not? So the angle subtended by CD at the center would be this, is it not? So basically, if I figure out this angle, I'm done. How can I figure out this angle? How can I relate it to DOT? How can I relate this to DOT? Anything? Yes, you can relate it to DOT with the help of congruency. So for that, we'll consider the first triangle being OCT and triangle ODT. So what do we have? We have OC is equal to OD, their radius. Then we have, what else do we have? OT is common. And since those two lines are perpendicular, we can tell angle OTC is equal to angle OTD because they are equal to 90, and this is because AB is perpendicular to CD. And at last we have the final answer to be what? Therefore, by what is it exactly? It says OC is the hypotenuse. We have a right angle and one side. So RHS congruency. So we have to be careful with what congruency we're dealing with. After writing so much, if you mess it up, that won't make sense, is it not? You have triangle OTC to be congruent to triangle OTD. So from this, what can we imply? We can imply that angle TOC is equal to angle TOT, and both of this are equal to 60 degree. Because this is equal to 60 degree, what do we end up with? Therefore, angle A, yeah, we can call it as angle A, is equal to angle half of angle this, which is equal to 30 degree. And the reasoning is, yes, angle subtended by an arc at the center is double the angle subtended by it at any point in the remaining part of the circle. That's a big statement. We need to write it. Angle subtended by an arc at the center is double the angle subtended by it with the circumference. So this is your answer.